This lesson is on congruence and transformations. Our vocabulary for today is dilation, isometry, and rigid transformation. A dilation with a scale factor k greater than 0 and center is 0, 0 maps x, y to kx, ky. A dilation is just about equivalent to the compression or stretch that we did with the other types of graphs that we did. In geometry, we're going to call it a dilation. In a transformation, remember the original figure is the preimage and the resulting figure is the image. For this application, we're going to go ahead and do the transformation M to the polygon with the given vertices. We want to identify and describe the transformation. So when we transform this, we're going up 4 units left and 1 unit up. With this example, we're going from x, y to x, negative y. So when we reflect it, we see that there's a reflection around the x-axis. So this is the summary of rules for transformations, which we've seen a lot already. A translation adds to the x value and adds to the y value. Previously we used h for x and k for y. Here they've used a and b. A reflection to go around the y-axis. Remember, when we reflect around the y-axis, that's a horizontal move, so we make x opposite. And when we reflect across the x-axis, that's a vertical move, so we change the y. Rotations, we haven't talked about too much. Rotations are relatively new. When you go around 0, 0, 90 degrees clockwise, you make x negative. Rotating around 0, 0 counterclockwise is going to make negative y, comma x. Notice that for both of these, we're flipping the x and the y values. When you rotate 180 degrees, we change x and y to be negative values without switching them. So that's going to be a new one that you're going to have to memorize. Also, we have a dilation. Dilations we already talked about. This is like our stretch or our compression with a function. You multiply x by the value or y by the value. An isometry is a transformation that preserves length, angle measure, and area. Because of these properties, an isometry produces an image that is congruent to the preimage. Remember, congruent means they are the same. A rigid transformation is another name for an isometry. Rigid transformations are very important with the new Common Core standard. We talk about them a lot in terms of congruence. Translations, reflections, and rotations produce images that are congruent to their preimages. Dilations with a scale factor k not equal to 1 produce images that are not congruent to preimages. So all of your types of transformations except for dilations produce congruent figures. So let's determine whether the polygons with the given vertices are congruent. So if we look from our preimage, which is in blue, to our image, which is in red, we can see that for all of them, we have subtracted 1 from x and subtracted 3 from y. Since this is a translation, they are congruent. They can be mapped by the translation x minus 1, x minus 3, y minus 3, excuse me. Here's another example where we have again, the blue image is our preimage and the red image is our translated image. And the triangles here are not congruent because ABC can be mapped by a dilation. And remember, dilations are the only transformation that does not produce a congruent figure. Again, we want to determine whether the polygons with the given vertices are congruent and support our answer by describing the transformation. So we're going from 2, negative 1, 3, 0, 2, 3, to 1, 2, 0, 3, negative 3, 2. Here, the triangles are congruent because ABC can be mapped by a rotation. They are flipping x and y and making y negative. Translations, reflections, and rotations can be called congruence transformations. So start your lesson quiz, try these few problems, and see if you have any questions. Bring your questions to class tomorrow, and we'll continue to work on this.